Hey, hey, hey! Here we are again. Periodic table of elements. Thought I'd give you a super quick tour so make your mole lessons a little easier. All right, what you have in front of you is the periodic table of elements. The periodic table of elements are organized by their atomic number, which is usually on top. Each element has their very specific own atomic number. It's the number of protons that the element has. But they're numbered 1 through, this periodic table is 1 through 117, being the last one right there. And if you look very carefully, it goes from 56 to 57. So this long bar right here, these are the lanthanides and actinides, actually fits right there. So if you were to draw the periodic table all the way out, it would look kind of something like that. But you don't see it shaped like this. You see it like you do in the colored part here, because we can't fit it on a sheet of paper when it's like this. So just to point out that section actually fits right here. Okay, elements 1 through 92. 92 stops right here. That's uranium. So 1 through 92 are what I like to call el natural. That means they exist on planet Earth, even for a short period of time, or some are more rare and some are more plentiful than others. Elements 1 through number 92 are found on planet Earth. After that, 93 plus, as we continue on here, and down on, these are all man-made elements. I think we're up to like 120 now, is kind of the last I've heard, but most of them are made in a particle accelerator, Berkeley University, out in the Arctic somewhere. But that's just kind of what you need to know. All right, when you're looking at the elements inside of this box, the number on top is the atomic number. This is the chemical symbol. Sometimes you will see the name. Now, in chemistry, we want you to memorize some of that, the name. And then you'll see the atomic weight, or what we call the atomic mass, at the bottom. Everything else here on the periodic table, like why there's a staircase-shaped part here, why they're all in different colors, and all of these different families, we will actually learn later. But you just kind of need to know how everything's laid out. There are what we call 7 periods. Periods are referring to a cross. There's 1 period. All of these elements here are in period 2. These are all in period 3. These are in period 4. So there are 7. There are basically 7 rows. Those are called periods. And there are 18 what we call families or columns. There's column 1, column 2, family 3, family 4, family 5, column 13, 14, and so on. And so that's just a little vocabulary for you before we move on. So what do we want you to know here on molar mass? Well, you're not always going to look at the elements on the periodic table. You're going to look at them in chemical formula form. So I just want to point out that if I'm looking at copper or if I'm looking at uranium, when it's written like this, capital letter, lowercase letter, that's one element. Capital letter, uppercase letter, like this would be carbon and uranium. And this is going to be copper. So just a note, that's how you can tell a difference. Before we learn about chemical formulas, you kind of need to know how to count them. Here I have carbon dioxide. In this formula, this little number right here is what we call a subscript. It's just attached to that oxygen. And carbon is written, but there's no number there. You can assume that it's a 1. We just oftentimes in science don't write the 1. Since the C is already there, it lets us know carbon's already there. Okay, so in CO2, carbon dioxide, there are 3 atoms. There are 1 carbon and 2 oxygen. If I have H2O, which is water, that little 2, it's called a subscript, is attached to just that hydrogen right there. So in H2O, there are also 3 atoms. 2 of them are hydrogen, 1 of them is oxygen. If I have, let's see here. disulfur tetroxide. Here, this little subscript right here, this 2 is attached to that S. So there are 2 sulfurs, and the 4 is attached to the oxygen. So there are 4 oxygen. So there is a total of 6 atoms. Okay, so that's how we can determine how many atoms are in each element. So if you have, let's do a little more complex one here. All right, that's a big compound, right? This compound has different elements in it. There's the little subscript that's attached to a hydrogen. There's an oxygen. You can assume that's a 1. Yes, okay. Oops, hold on a second. And there's another carbon, and then there's 2 more oxygen. So this atom right here has 3 hydrogen, 1 carbon, and 3 oxygen, if that makes sense. Because even though they're separated out right here, it's still a hydrogen, and that's still a hydrogen. So we would say that this atom has 1, 2, 3, 4, 5, 6, 7 different atoms. Okay, now that's important because what we want to determine is the mass, or also what we call molar mass. Molar mass has a unit as grams per mole. We're going to determine the molar mass of this compound right here. This compound has carbon, hydrogen, and oxygen. There are 6 carbon, 3 hydrogen, and 2 oxygen. To make this a little easier, I have put right here hydrogen, carbon, and oxygens, what they look like on the periodic table. And we're going to need that mass. So, since there's 6 carbon, we're going to multiply 6 times the actual mass of carbon, 12.01, and hydrogen, 3 times 1.01, and oxygen times 16. We basically want the sum of all the atomic masses, or the sum of all the masses inside of this compound. That's how we get molar mass. Alright, so 6 times 12.01 is 72.06, and 3 times 1.01 is 3.03, and 2 times 16 is 32. Okay, now we want to total all of those up. So 32 plus 3.03 plus 72.06 is 107.09, and that is grams per mole. All right, and this is how we get molar mass. The sum of all the masses create this unit of grams per mole.